Buckle up for a cosmic journey with us as we delve into the future of humanity and the challenges we face in the vastness of the universe. From climate catastrophes to galactic collisions, we explore the ultimate fate of our species and the quest for survival beyond the bounds of Earth. What is the ultimate destiny of our species in the cosmic theater? Merely 70 millennia ago, human existence hung by a thread due to the catastrophic eruption of the Toba supervolcano. Words become redundant in the face of an event of such magnitude. However, the shadow of a similar calamity still looms over us, with the possibility of another cataclysmic eruption within a 10,000-year horizon. Supervolcanoes are just one piece in the mosaic of threats capable of challenging the survival of our civilization. As we journey forward in time, we confront a universe fraught with uncertainties and imminent dangers. In today's content, we'll delve into the potential threats lurking for humanity, aiming to prepare and safeguard the continuity of our civilization. We'll explore threats so vast they could obliterate even an advanced society, a civilization extended across the arms of our galaxy. So, without further ado, let's kickstart this enlightening journey. There's much to cover, and the clock is already ticking. Humanity teeters on the brink, facing the grave consequences of climate change, a legacy of our own making. It's inevitable that discussions on this topic flare up, but the issue demands urgent attention. The relentless rise in Earth's temperature pumps more energy into the atmosphere, fueling the occurrence of extreme weather events. From torrential rains to prolonged droughts, these phenomena are becoming more frequent and intense. The effects? Infrastructure demolished and a threat to our food production capability, a central pillar of our existence. Looking at long-term perils, the melting of ice masses, like the Wilkes subglacial basin, could raise sea levels by up to 4 meters over millennia to come. However, it's the enduring excessive heat that threatens the essence of our advanced civilization. An overheated planet could corrode our industrial and scientific potential, diminishing our capacity for technological innovation. In this scenario, technology faces hurdles, and we become vulnerable to extinction from any spontaneous cataclysm. The lack of technological advancement leaves us defenseless against the inevitable. The path to overcoming this challenge involves not only adapting to and mitigating the impacts of natural disasters. It's imperative that we pursue more sustainable energy alternatives, focusing on the modern holy grail, nuclear fusion. This technology promises to revolutionize energy production, eliminating dependence on polluting sources and paving the way to explore the cosmos. Mastering nuclear fusion could be the key not only to a clean energy matrix, but also to realizing the vision of an era of space exploration, which, though seeming like science fiction now, is necessary for the future survival of our species. We'll delve deeper into this possibility shortly. If we master the skills to navigate Earth's extreme weather events, we can ensure our survival for the next million years at least until we face a hyper-extreme event. Catastrophes like the impact of a sizable asteroid or a supermassive volcanic eruption, akin to Yellowstone, should not be trivialized. Supervolcanoes pose a tangible threat, capable of unleashing immediate and widespread destruction. However, their true threat stems from their potential to trigger a rapid and drastic climate change on our planet, inducing artificial winters that could last for years, thereby impairing humanity's ability to produce food. For civilization to endure over the ages, we must have contingency plans for both mitigation and recovery to prevent such an occurrence from wiping out our achievements and aspirations. It's imperative to understand that these types of threats may not affect us within our lifetimes. However, adopting a broader view, encompassing all of humanity, the odds are not in our favor. For instance, it's nearly certain that within 100 million years, Earth will face another impact of a scale akin to the one that wiped out the dinosaurs. We'll likely have vanished by then, but future humans, if any remnants exist, will have to grapple with this dilemma. Fortunately, our ability in asteroid management is advancing, as evidenced by NASA's DART project. We've already managed to alter the course of an asteroid through deliberate collision with a probe. Furthermore, with a catalog of known hazardous asteroids under constant surveillance, we're making progress in planetary defense. But the next few centuries remain critical, as our capabilities to avert asteroid threats are not yet fully mature. Nonetheless, these skills will become crucial in 1,000,000 years when an unwelcome visitor enters the solar system. The star Gliese 710 is on a collision course with our solar system. Its close encounter with the Sun will trigger severe gravitational disturbances within the Oort cloud, a distant repository of comets at the edge of our system. This disturbance is likely to redirect comets toward the inner solar system, precipitating an immense comet shower. The high probability of at least one of these comets striking Earth, combined with the risk of a gravitational ejection of our planet from the solar system, is a vivid reminder of the fragility of our existence. In the absence of space colonies, such an event could spell the end of human civilization, which, at this point in the video, would have lasted no more than 1,000,000 years. And this stellar visitation is just one of the countless potential calamities threatening Earth in the coming millions of years. It's a matter of when, not if. To ensure the perpetuation of humanity across cosmic time, venturing beyond the bounds of Earth is not just an aspiration, it's a necessity. Establishing self-sufficient colonies on Mars, Jupiter's moons, and even within the vastness of space aboard generational ships could exponentially extend the existence of our species. Properly executed, this could ensure human survival until the twilight of our solar system, estimated to be about 4 to 5 billion years from now. However, the specter of gamma-ray bursts looms over this grand plan. These surprisingly potent cosmic events have the capacity to destroy life across an entire solar system in brief moments. When a star, with more than 8 times the mass of our Sun, exhausts its nuclear fuel, it culminates in a supernova explosion, releasing immense energy. Amidst this cataclysm, gamma rays, a form of high-energy radiation posing a serious threat to any form of life, are unleashed. Fortunately, the most severe effects of gamma rays are confined to 2 narrow beams escaping the supernova. Thus, even if one were to occur near our solar home, it's unlikely that these harmful beams would intersect with our solar system. Despite their rarity, even improbable events are likely to occur given enough time, and it's more likely than not that our solar system may face a gamma-ray burst from a supernova in the next 500 million years, an encounter for which there is no known shield. An impact of this magnitude would have catastrophic consequences. Carbon-based molecules, the very building blocks of our existence, would be shattered by the relentless radiation bombardment. And it's precisely these carbon molecules that make up the fabric of human life. Thus, while colonizing our local celestial neighborhood could secure us a few 100 million years, or perhaps even 1 billion years of grace, if luck smiles upon us, it's not a permanent solution. Survival beyond the 500 million year mark requires an exodus from the solar system as a whole as we embrace the stars, in search of a new refuge for humanity's immortal spirit. Venturing beyond the confines of our solar system within a human lifetime is imperative if we are to ensure humanity's continued existence. The journey to the nearest stars will not be brief, spanning several decades. However, the long-term vision involves transplanting a sufficient number of our species to thrive and propagate on alien soils, far removed from Earth's cradle. It's an odyssey fraught with profound challenges to effectively colonize the galaxy and establish self-sufficient outposts is an endeavor that currently surpasses our technological capabilities. Therefore, we turn to the realms of science fiction for inspiration. One of the less conventional methods proposed for galactic colonization is the generational ship, a microcosm of society traversing the void. Instead of transporting humans incrementally, this concept involves mass embarkation, necessitating the transportation of entire ecosystems required for survival, nutrition, hydration, and energy. The viability of such a colossal spacecraft is yet to be seen, and alternative solutions hinge on scientific breakthroughs that, at present, we cannot even be sure are attainable. These include the quest for biological immortality to eliminate aging and disease, thus allowing the luxury of time during interstellar travel. Alternatively, the prospect of cryogenic stasis presents a theoretical means of efficiently transporting dormant populations through the stars. However, both scenarios involve pioneering technologies that may verge on the impossible. A more pragmatic approach to space colonization may lie in conquering the formidable obstacle of consciousness, learning to transfer human minds into machines, entities much more adept at weathering the rigors of space. Thus, humans could become the very ships sailing the celestial seas. However, this path faces some of the most intricate scientific and philosophical dilemmas. If we can disseminate our species throughout the galaxy, becoming an interstellar civilization, we would effectively render humanity nearly invincible. The only phenomenon capable of impacting a civilization of such scale is the cataclysmic event of galactic collisions. The impending merger of the Milky Way with the Andromeda Galaxy, 5 billion years from now, represents a conceivable threat, with the potential to hurl star systems into the cosmic abyss due to gravitational disturbance. Our strategy, therefore, must encompass widespread colonization of the galaxy to mitigate the risks posed by such an event. With ample time, 5 billion years patience could even lead us to one of the numerous dwarf galaxies orbiting the Milky Way. Achieving galactic dominance promises the ultimate reward for our civilization, a place to witness the universe throughout the stellar age, reaping a prosperity lasting 100 trillion years. The final frontier of human survival emerges as our most enduring legacy. Let's begin. 100 trillion years may seem like an eternity, but even eternity has its end. The feeling that the days are long, but the years are short, resonates deeply when contemplating such a vast expanse of time. Within the span of 100 trillion years, only a handful of stars will continue to shine in our galaxy, which will have transformed into an entirely new entity, a colossus born from the amalgamation of all galaxies in the local group. When the last stars extinguish, the era of stellar light will conclude, leaving behind no new celestial bodies to ignite and no usable energy within the universe. If humanity reaches this point unprepared, we risk fading into oblivion alongside the last of the stars. To go beyond, to inhabit the starless universe, humanity must shift its civilizational mindset post-galactic conquest. The ideal moment to initiate this shift is when the last of our local galaxies merges with the Milky Way. No additional galactic events will occur beyond this point. Humanity's focus must then turn to conserving hydrogen as our lifeline beyond the natural death of stars. If expansion is the first step to survival, the next is to prevent stars from rapidly depleting their energy reserves. This proactive approach could redefine the history of the universe and buy time for life to persist even as the cosmos fades to black. Perhaps the 100 last stars burning in the galaxy could serve as humanity's sanctuary, their longevity guaranteed by our careful stewardship of hydrogen reserves. Or better yet, humanity could tap into the ultimate cosmic energy source, black holes. Black holes are unparalleled in their ability to generate energy through the absorption of matter. To explore this, we must learn to create a cosmic dam, harnessing the flow of gas flowing inward and capturing the light from the surrounding accretion disk, to generate power. These disks can shine brighter than stars and offer a tremendously efficient method of energy production. Living in proximity to a black hole and utilizing it to obtain energy could potentially maximize our lifespan in the universe. Black holes will exist for trillions upon trillions upon trillions upon trillions of years beyond our current concept of time. If we occupy the universe for even a fraction of that time period, it would be a remarkable achievement. Frankly, a lifespan of 100 years seems quite satisfactory for an individual. Essentially, the longevity of civilization is tied to the breadth of our cosmic explorations. If we remain tethered to Earth, our extinction within a few million years is conceivable. Reaching the solar system may extend our existence for nearly 1 billion years, while conquering the galaxy could ensure our place for hundreds of trillions of years or more, depending on our discipline in resource management. But what about you? If you were to hazard a guess about humanity's resilience, how many years do you believe we have ahead? Ready to explore cosmic mysteries? Click the subscribe button and enable notifications to stay updated on our journey through space and time. Don't miss out on the discussion. Like, comment, and share your predictions for the future of humanity.